Hello Math 1B, I'm back with the 11th lesson of remote learning. Again, it's another review lesson throwing back to graphing linear equations. So, hoping it'll be a pretty easy one for you guys. So let's get to it. First thing I want to highlight is that every equation should have this as sort of like its standard default setting. When you have y by itself, the number in front of x represents the slope, also known as the rise over run. That's kind of telling us how steep the line will be, how far it will go up or down, and then left or right. You'll see how that plays into this when we go through an example. The b is just another name for the y-intercept. I call it the starting point. Because it's usually the first point we plot when we're graphing any of these. So when you think of y-intercept, it's the place where it crosses this vertical axis. So the starting point, the first point you plot on the y-axis is the constant not multiplied by x. So when we look at our first example, y equals 5 minus 2/3 x, I'm just going to use the commutative property to rewrite it as y equals negative 2/3 x plus 5. I think this is a much easier way of looking at it because we've sort of got our default equation where y equals mx plus b. Now we've got our equation that looks exactly like y equals mx plus b. We just have the numbers to fill in. So what's m? M is negative 2/3. Now this means two things. It means you can plot a point, go down to right 3, because in order to create a negative, you'd have to take a negative divided by a positive, or you could think of it as a positive 2 over negative 3. So these can both guide our slopes. The b value is just plus 5. And we've got enough information now to graph as many points as we can. So, b equals 5. That means we're going to plot a point on the y-axis 5 units up from the origin. So here's the origin. Go up 1, 2, 3, 4, 5. Make a point. Then what we're going to do is we're going to go down 2, right 1, 2, 3. Plot a point. Go down 2, right 1, 2, 3. Or go up 2, left 1, 2, 3. I like to plot as many points as I can on the graph that's given, so I think that's about all we can do. And that's it. Notice a negative slope will point the line downward. Next one, y equals 4/3 x minus 6. Well, right away, it's already in slope-intercept form, so 4 over 3. By the way, that's slope-intercept form. M is equal to 4/3, which means it's a positive over a positive, or a negative over a negative. The b value is minus 6. So right away we know we're going below the x-axis. Down 1, 2, 3, 4, 5, 6 on the y-axis. Then we go up 4, 1, 2, 3, 4, right 1, 2, 3. Up 1, 2, 3, 4, over 1, 2, 3. I can't really go down and left enough, so I'm just going to plot the points I've got, or keep those points and then connect the dots. Let's check out a few others. The only thing different about number 3 is that it's nothing but whole numbers. And a lot of times that throws students off. When they just see 2 plus 4x, they're like, I don't know, maybe the starting point's 2, maybe the starting point's 4. Remember, if we reverse the order of these using the commutative property, we can call it 4x plus 2. And if that doesn't show it enough for us, we can also say the x term, that's the slope. So I need it to be in fraction format. If it's not already a fraction, I can easily make it a fraction by putting 4 over 1. Now I've got my m, and I've got my b. I can also call m negative 4 over negative 1. Yeah. So start on the y-axis, 2 above the origin, plot your point. The slope then, from there you'd go up 1, 2, 3, 4, right 1. Or, as our alternate version of the slope, go down 1, 2, 3, 4, left 1. Down 1, 2, 3, 4, left 1. Number 4, this one oftentimes gives students problems because instead of nothing but whole numbers, I give 2 fractions. And again, it's like, what am I supposed to do with a fraction like that? Here's what you do. Well, first, let's put it in order where it's y equals mx plus b. Well, in this case, minus b. Our slope is 3/4. Or negative 3 over negative 4. Now the b value is negative 4/5. I think a lot of times students want to say, okay, so if b is negative 4/5, that means I go down 4, right 5, and plot a point. But then it wouldn't even be on the y-axis. What we're doing is we're saying, plot a point 4/5 of a block, if our blocks are 1 unit of measurement, go down 4/5 of a block and plot your first point on the y-axis, 4/5 of a block from the origin going below it. So, I can't really zoom in right now, but right here is 1 full. I'm going to go just a little bit less than that. Or I guess it'd be greater than because it's closer to the x-axis. But basically, this is like negative 4/5 or 0.8 down. Okay, from there, you just have to make sure you use that as your reference point when you're plotting new points. So we shouldn't be plotting any points on corners of blocks because that would represent like you're moving now to a whole number, but we're kind of stuck on the negative 0.8 issue here. Here's what I mean by that. You're going to go up 1, 2, 3, right 1, 2, 3, 4. I'm still now above this whole number grid line. Right? You see what I mean? It's like this is not on a whole number grid line. It's at 0.8. This is sort of like 0.8 below that whole number grid line. So sometimes kids can get confused with that. Students can get confused with that. So then you go down 1, 2, 3, left 1, 2, 3, 4. You've got 3 points. That's a pretty good measurement to graph a line. You technically only need 2, but why not graph 3 if you can? All right. Seems like we covered everything, but I got a few more that I want to highlight. This one isn't really any special, number 5. I just wanted to show you that if it's negative 4 for your m, don't put it over negative 1. Make sure you put it over positive 1. I've seen students make that error quite a lot, where they go down 4, but then they'll go left 1. This should be down 4, right 1. Okay? So y, x, our m is going to be negative 4 over 1, or technically 4 over negative 1. They'll both plot the points on the same line. And then our b is equal to positive 6. That means go 6 above the origin on the y-axis. Then you're going to go down 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1, down 1, 2, 3, 4, right 1. And then this one's definitely different. It doesn't have two quantities to it. It's like every single other one had an x and then a b value. This is just y equals 1/4 x. So what are we supposed to assume about this unknown? Well, the numerical equivalent for nothing is going to be 0. Okay? So m is equal to 1/4. Our b is 0. That means it's directly on the origin. So then you go up 1, right 1, 2, 3, 4, or down 1, left 1, 2, 3, 4. All right, that's all I got to say about graphing. There are two examples where I want you guys to be able to do the reverse. What I mean by that is I'm going to give you that line, and then your job is to produce what the equation is. So I got two examples for that. All right, so starting with number 7. Our goal is to say, I want to fill in the missing pieces that accurately describe y equals mx plus b for this particular line. So, this is our very first point. I mean, it shows us where it crosses the y-axis. It's got to be the b value. So, it starts at 0, 3, which means b is 3. I wrote it out like this on your homework. The answers that I provided kind of look like this. So then you got to figure out where is another for sure point that's on this line. And if you look closely enough, I put a really big dot there to just highlight the fact that I want this dot to represent a point on this graph. Well, to get from here to here, its rise over run is down 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6, 7. So it goes down 4, goes right 7. So that means that m is equal to down negative 4, right positive 7. It's negative 4 sevenths. So all we're doing is we're saying, take this sort of like template, yeah? This is our template for a line, and we're going to say the m, y equals m, is negative 4 sevenths. It's multiplied by sort of a placeholder x, so you always got to have your x there, plus b is 3. And that's all I'm asking you guys to do. You are writing the equation of the line, given the fact that you're using your knowledge of the starting point and the rate of change, the rise over run, the slope. So then our last example. Our b value is 1. So it's y equals something x plus 1. And then at this point, it's the rise over run is I go up 1, 2, 3, right 1. So it's weird. It's like m is equal to plus 3 over plus 1 when you just take these two data points. But if I were to go from here to here, 1, 2, 3, 4, 5, 6, right 2, which one of these am I supposed to use? Well, they both equal 3. The slope is 3. And if you don't feel comfortable with a whole number there, put it 3 over 1. All right, see you guys.